name is James Kwan, and PhD candidate, also CEO of the company named airple. So I'm going to introduce the Smart City Air and Air Carbon Environment Lab. Okay, so we have participated in the same program that you are doing today. So it was second semester of 2020. I took the course Introduction to Smart City Global Convergence, instructed by Professor Huang, and from a startup team, airple. Actually, original team crew name was Team 7, but it has been changed to the company name later. So the topic what we have presented at the 2020 region-based air quality measurement platform using IoT and digital twin technology. So here are the members. So this is the background, how IoT works. There's some RFID or sensors collecting data, and a smart tech enhance the power of the network, and the nanotech to make small and small things have the ability to connect and interact. So making smart cities sustainable, collect the gather data in real time from smart devices, sensors, and connected objects via Internet of Things and ICT platform. Communicate, make the data available for all decision centers such as automated system, government institution, telecom providers, infrastructure managers, and citizens, ensuring interoperability, integrity, scalability, and privacy of this data. Analyze, compute the data to build actionable result. Act, the transport actionable result in social initiatives, environment improvement, behavior influences, and infrastructure optimization. So the background is that the lack of oxygen in the urban life because of the air quality is getting poor, getting worse because of much traffic, urban daily life happen naturally. So we need some more O2, oxygen. So how we can solve this? This could be solved by forest or some of the some natural side. So we have found that urban park space allocation size for cities is not that big enough. So normally we have found that one Korean citizen's mean space was 9 square meter, while other having 2 or 3 times more height than us. So urban forest park is an air purifier for the city. Normally, urban park has many green spaces. By including big forests and trees. This has been regarded as natural air purifier, whilst every home having such air purifier device to clean the air in their home, because we cannot have such large scale of city air purifier. So it is very much clear that we should have many urban forest park to make it clean the air quality and supplying up. So we have studied some case studies. So this is one of example forest cities. Architect Stefan Bori, passionate about green infrastructure, demonstrate the art of the possible with this fantastic looking plant covered building. It was one of example what we have found as a case study. And the other one case study was beyond the biggest 5. Aaron Koch is Chicago's first chief legislative officer. One of the challenges he was taking storm water management. He was trying to solve this by having the some natural resources rather than just using their some pipelines getting bigger. Also, we have found that the present data collect system is there's some limit. because the KT we have found right to air map, which just supplying the today's data, but we couldn't find that's the big data, monthly basis, yearly basis, periodic report. Also, there has been no pre-research to show the quantitative air quality enhancement checkup through urban forests by using some particular measurement method. So IoT big data measurement we should bring into this problem to solve. Also, AI need to be checked out. Also, can predict for humans better life. So our goal was urban park, how much is effective for people in the urban city. So urban landscape, how much it can help to reduce pollution and helping to increase oxygen. That was the goal of our project. To do that, we want to collect the IoT data and bring it to the, by using AI to check out how much it was effective. So plan was, this is the block diagram of our IoT device. This is the CPU and storage, sensors, real-time clock. So it's keep collecting data. This data can be utilized by using the from the digital twin process. So how we can adopt data from the device to the digital twin technology. This was another homework that we have done. That IoT getting the data from big data and simulation and visualization and implementation. This could be happen in digital twins. Also, this is the real data what we have collected, such as Sihyung and Gwanak. When you see the air quality is dramatically such poor compared with the other area. You see that the Gwanak was 65 for the fine dust, although the Sihyung was 179, which was very, very high. So our plan was to compare the Gwanak campus and the Sihyung campus. Currently, Sihyung campus is still in the process being built. A smart air quality system will simulate the atmospheric environment as cost of construction. It can reflect this result in the planning process, apply optimal planting environment plan on campus to actual site. So, like I said, that this is the air quality, but we have found some interesting point that this is the nearby Sihyung campus. Like this point that is very poor, 147, so find this. In the meantime, we have tried to check up some other area which has a green forest. It's 7.6. It's the same date and the same period, but it dramatically changed. That value has been increased. Very nice because of the Suri Mountain, which is a little bit bigger, and then it has helped that air quality was improved. So this was planned. What we have proposed first phase, second phase, and post. Interesting to the device was this was target platform, and it can check out the fine dust, also CO2, humidity, temperature, TVOC. So what guys was one that we have developed and using in the soil forest. This was the first prototype. Okay, so this has been set up in a soil forest, and keep going on the study. I have keep monitoring and collecting data. Oh, so okay, so we have got some training from Professor Wang, and then we applied the patent through the participant in 2020 Winter Vacation Startup Consulting Camp. This was one of the patent, and then we have had some brand name or the company name, airple. So smart air quality management platform. That was our target So we started to set up, and then we could get some grand prize in the August 2021 last year from the Gyeonggi Smart City Idea Hackathon. We got a grand prize. Also, we have had the MOU with the Grade School of Environment, so Department of Landscape Architecture and the Korean Landscape Architecture Society. We had MOU regarding some smart park solution. And this was the product that we have applied last year for some government project. It has a remote monitoring system and IoT air quality checker. I set up the system into rooftop of the Sing campus. I have developed this for 2 months. This is prototype. Also, this is the Smart Park presentation webinar. June 2021 monthly webinar, Korean Institute of Landscape Architecture. I presented about the smart park. And then I have submitted this. And the other one that I have submitted is lately, AI-based remote air quality monitoring system, human data detection, Korea Society of Environmental Technology. And so last year, July, set up the company finally in Seoul National University. So airple carbon environment lab. So focusing on the Korean government policy, climate changes, save the world. We do some the related works. So also thanks to the hackathon prize, we got an office in Future Mobility Technology Center, which is located in Seoul campus. Also, we have submitted some patent thanks to the Professor Park and the Professor Huang supporting. So this one was the additional one more, the system and method paying compensation carbon reduction activity using air quality information based on artificial intelligence. Second one was system and method monitoring indoor space using air quality information based on artificial intelligence. So, and then I have, participated in one the program, the 500 startup in the Silicon Valley. I kept learning about 3 months, got the certification finally. Also, I have participated in final. We have entered the final of Smart City Idea contest for graduate student Ministry of Land, Infrastructure and Transport. This was the feedback, remote air quality monitoring system. The problem was that the air host couldn't see the gas inside because of privacy issue. CCTV, everything is prohibited. And then solution was to check out the air quality, then monitoring the state inside. So I also have set up the similar demo system in your lab in Sing campus. The target market is likely home broadband or inside of car sharing market. This is one real example what I have seen that lately. AI-based air quality remote monitoring sensing for human status check. I'm doing this research in Suwon, Spain building. This is a real demo. This is a little bit long. So actually this is my building, and then you could see that one guy is keep moving around because he has some issue from his room. Actually, he was keep trying to find something to help, but there has been a big fire in his lab. So the much smoke keep blowing out, and even we can see some flame inside from this room. And 8 minutes later, Okay, nobody can help this out, but I see monitor and I ask somebody to fire. I mean, using the fire extinguisher, and then he has off the fire. It's very dramatic. So several after that, then fireman comes and it's getting better. Policeman comes, it's so late. So if it keeps firing, then it's big issue. Okay, so this is a real situation. How much it was a problem? Actually, there has been a fire extinguisher in the room, but he doesn't know how to use it. That's why it has been growing a much more bigger issue. So many policemen and firemen come to the building to this. It was very emergency case. In the time, I also check out air quality. There has been formaldehyde, temperature, humidity, dramatic change, and then VOC value, CO2 value. So like this case, you can check out the air quality and the human state inside, how much is difficult and dangerous. So this is my whole story. Thank you very much, everyone.